Today I will discuss about statical electricity. Before going into the topic, I am discussing about the source of charge. We know that in atom, electrons are orbiting around the nucleus, and nucleus is positively charged. Nucleus consists of proton and neutron. Proton is positively charged and electron is negatively charged. This is positive. Charge of each electron, E, is equal to 1.6 into 10 to the power minus 19 Coulomb. Coulomb is the unit of charge. And also the magnitude of the charge of proton is equal to 1.6 into 10 to the power minus 19. But electron possesses negative charge, but proton has positive charge. They are equal and opposite. And as the number of proton in nucleus is equal to number of electron in the orbit, so as a whole, an atom is neutral. But when electron comes out from the atom is converted into positively charged because number of proton is greater than number of electron. And when that electron enters into another atom, it becomes negatively charged. So charge, either it is positive or it is negative, that is due to the excess of electron or deficiency of electron. Proton cannot move as it is much heavier than electron. It is at about 1836 times heavier than electron. So it cannot, and also it is strongly bonded inside the nucleus. Now, how we can charge a body? It is observed that if you rub a glass rod by silk, that rod is converted into negatively charged. Negatively charged, why? Because during rubbing, due to friction, electron which is loosely bounded with the silk comes into the rod and it is converted into negatively charged. On the other hand, silk which shares that electron, that converted into positively charged. We know that total charge in the inverse is constant and we cannot create or destroy the charge. Only it can transfer from one body to another body. Now, this is a mechanical process of charging a material. There is another process which is called method of induction. Method of induction. By this process, if a charged object comes closer to another body, suppose this is positively charged, and it comes closer to a body which is neutral, it may be conductor or insulating material. When it comes nearer to the body, we know that positive charge always attract negative, and this material consists of electron and proton. Electrons are orbiting around the nucleus, so that electrons are attracted towards the body. So this side of the material get negatively charged, and at the same time, as this body is neutral, so the opposite charge accumulated on the other side of the object. If you move this charged body far away from this object, then again they come closer and there will be no polarization. This is called polarization. There will be no polarization. Now you can charge this body by method of induction. How? If you connect this part, opposite part, with earthing, then this charge will go through the conductor, and then if you disconnect this earthing, the whole body converted into negative charge. In this way, we can charge a neutral body by method of induction. Lightning conductor. What is that? This is fitted to resist the Thunderbolt, and it is a sharp-ended conducting rod. It is fitted at the top of the multi-story building or a tower, and end of this is connected with the ground. Now, when the cloud, which is charged particle, come nearer to it, this charged cloud create a vector electrostatic field surrounding Earth, and the electrons of the conductor, if it is positive, then electron of the conductor accumulated at this point at the tip of the, and the positive charge earthened by the earthen conductor. Now, when the gas molecules surround this earthen conductor come in contact with this and get negatively charged, and we know that when it is, this conductor is negative and the gas molecules which come in contact with it also converted into negative, so they repel each other. As a result, these air molecules move away from the conductor and mixed with the cloud. This is negative air particles, so when it come in contact with this positive cloud, they nullify each other. In this way, the potential of the cloud reduces and reduces the possibility of thunderbolt. Now, how to measure the quantity of charge? This is by electroscope. This is a simple instrument. There is a metal disc which is connected at the end of the rod of aluminum foil. Very thin aluminum paper are fitted, and this whole setup is kept inside a glass container, glass box, so that it is visible from outside. Now, if a charge, suppose there is a charged object, when it comes in contact with this, if it is positive, then it will induce a negative charge here, and it at the opposite phase it becomes positive. Greater the magnitude of the charge, greater will be the induced charge, and also greater will be the charge in the farthest point. And greater the charge, they will repel with greater force, and the deflection of the leaf will be greater. So by deflection, we can measure the quantity of charge inside the body. And if this body come in contact with this, then it will share the charge. As a result, if it is positive, the total rod become positive, and it will be equally distributed over the conducting rod and also in the leaf. So again it will be deflected, but the deflection will be less than the previous because charge is spreaded over the body. Now the Coulombs law of electrostatics. According to Coulomb law, if two-point charge separated at a distance of r, if it is charge is q1 and this is q2, then the force is proportional to product of the charge and inversely proportional to the square of the distance between them. This is very similar with the Newton's law of gravitation, but the constant is different. F is equal to 1 by 4 pi epsilon 0 into q1 q2 by r square. This is a constant of proportionality. The value of 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9. Epsilon 0 is the permittivity in vacuum, that is the characteristics of the surrounding medium, and if medium changes, this value also changes. That is why Newton's law of gravitation, G, is called universal gravitational constant, but this is not universal constant because it depends on the surrounding medium. Now, the direction of force. We know that like charge repel each other and unlike charge attract each other. So Q1, Q2, if any one become negative and another positive, then this will give a negative result. Negative result, that is force of attraction. If both have same sign, then they will give positive. So positive means force of repulsion, positive force of repulsion, and negative force of attraction. Now, what are the limitations of Coulomb's law? Coulomb's law only applicable for point charge. We can't apply this law to extended object. Only exception is sphere. In that case, we consider that all the charges are concentrated at the center of the sphere, and center is taken as the point charge which contains the whole charge of the sphere. Other than, we can't apply Coulomb's law in case of extended object. Now, the vector form of Coulomb's law. Suppose this is the origin and there are 2 point charges Q1 and Q2. The position vector of Q1 and Q2 are respectively R1 and R2. This is R1 and this is R2. Now, this is a force on the charge Q2 due to Q1. We are naming this like this, 2, 1, charge on 2 due to 1. And this is force 1, 2, charge force on 1 due to 2. Now, it obeys the Newton's third law, that is F21 is equal to minus F12. Minus 1 F2, this is vector, this is vector. And suppose this is O, A, B. Now we know that AB is equal to OB minus OA. OB is equal to R2 minus R1. So direction of F21 along this direction. If we name that 21, then direction of F21 is equal to along 21, which is along AB, that is R2 minus R1. Now F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square R2 minus R1 mod square, and the direction will be unit vector along R21 cap, that is Q1 Q2 by 4 pi epsilon 0 R21 square into R21 cap. This is a vector representation of the Coulomb's law. Now, what will happen if there are several numbers of point charges? Suppose this is a point charge, this is another charge, this is another charge, Q1, Q2, Q3. We have to apply the superposition theory, that is net force acting on this charge will be resultant force of this and this charge. So, suppose this is F1, this is F2, and if there are any other charge, say, then we can say that this is, we are naming this like Q only, and this is Q3, and it force be F3, then resultant force on this is equal to vector summation of F1, F2, F3 and so on. Now I will discuss about some problems. A charge of magnitude Q is divided into 2 parts, Q and Q minus Q, such that the 2 parts exert maximum force on each other. Calculate the ratio. Suppose these 2 charges are separated with the distance r, and one is Q, small q, and another is capital Q minus Q. Now force exerted equal to F is equal to 1 by 4 pi epsilon 0 Q into Q minus Q by R square. So we can say that force will be maximum if Q into Q minus Q is maximum, that is F is maximum when Q into Q minus Q is maximum, because other factors are remain constant. 1 by 4 pi epsilon 0 is constant and R square is constant. Now suppose this is Y is equal to Q into Q minus Q square. Now it can be written as, this can be written as minus Q square minus Q into Q is equal to minus Q minus Q by 2 whole square minus Q square by 4. That can be written as, therefore Y is equal to Q square by 4 minus Q minus Q by 2 whole square. So Y will be maximum when this quantity become minimum, because Q has a constant value, capital Q has a constant value, but the small q is variable. So the minimum value of this will maximize the value of Y. As a result, we will get maximum force. So F will be maximum if Q minus Q by 2 is equal to 0. So Q is equal to Q by 2, that implies Q by Q is equal to 2. Next problem, two small spheres each of mass m kg and charges q coulomb are suspended from a point by insulating threads each of length L meter but negligible mass. If theta be the angle between each string mixed with the vertical, then when equilibrium has been reached, find the value of q. Okay. Now, two spheres are identical. They have identical mass and charge. So they repel each other and form an isosceles triangle. Suppose this is an isosceles triangle and one mass is, another sphere is this, and they repel each other. So the line joining their centers like this. Okay. Now, if we consider one of the sphere and tension of the string acts along this direction, weight of the object acts vertically downward direction, this is mg, and force of repulsion acts along this direction, and that is 1 by 4 pi epsilon 0 q square into r square. What is the value of r? That is separation between these two. There is a r, and it is given that this angle is theta and the length of the string is L. So we can say that r by 2 is equal to L sin theta. From geometry we can write it. So r is equal to twice L sin theta. Now, if we break the tension in two components, one against the vertical direction which balances the weight, and another against the force of repulsion. So this magnitude will be t cos theta and this will be t sin theta. Now r is equal to this, and t sin theta should be equal to, due to equilibrium, t sin theta will be equal to q square by 4 pi epsilon 0 r square. R square is equal to twice L sin theta. whole square. That is equal to q square by 4 pi epsilon 0 4 L square sin square theta. T cos theta is equal to mg. Therefore, dividing these two equations, we can get that tan theta, sin theta by cos theta is equal to q square by 4 pi epsilon 0 4 L square sin square theta divided by mg. Therefore, q square is equal to 4 pi epsilon 0 4 L square mg sin square theta into tan theta. Two identical conducting sphere having charges q1 and q2 respectively, they come in contact and separated. What will be the charge on each sphere? Since spheres are identical, they have same equal capacity, and when they come in contact and separated, then charge will be equally distributed. So each sphere contains q1 q2 by 2. Two identical conducting sphere having charges q1 and q2 respectively and separated at a distance r. A charge q is removed from the sphere which carries q1, carries charge q1. Find the charge on each sphere for maximum electric force between them. Now, these are the two charges q1 and q2. If we transfer q charge from this point to this point, then the charge will be minus q and this will be plus q. For what value of q we can get maximum force of repulsion? Now, they are separated on the distance r. Now, the force of repulsion F is equal to 1 by 4 pi epsilon 0 q1 minus q q2 minus plus q divided by r square. So it is clear that the force depends on this variable part, mainly q1 q, and these remain constant. So we will get maximum force when this product of these two will be maximum. So let y is equal to q1 minus q into q2 plus q. That is equal to q1 q2 plus q into q1 minus q2 minus q square is equal to q1 q2 minus q square minus q into q1 minus q2 is equal to q1 q2 minus q minus q1 minus q2 divided by 2 whole square minus q1 minus q2 divided by 2 whole square. This can be written as like this. So q1 q2 plus q1 minus q2 whole square divided by 4 minus q minus q1 minus q2 by 2 whole square. Now it is clear that q1 q2 are constants. So this whole part is constant. So value of y, whether it is maximum or minimum, depends on this value. Maximum, it will give minimum, and if it is minimum, then it will give maximum value. We want to get the maximum value, and we know that the minimum value of a square is 0. So q minus q1 minus Q2 should be 0 for maximize the force. So Q is equal to Q1 minus Q2 by 2. So we have to transfer Q1 minus Q2 by 2 charge. Now what will be the charge after transfer? So in the first one, the charge will be Q1 minus Q2 by 2, that is equal to 2Q1 minus Q1 plus Q2 by 2, Q1 plus Q2 by 2. This is very interesting result, which is equal to the previous problem. So if we transfer charge from one point to another, the maximum force will be when they are equal. ABC is an equilateral triangle having sides 20 cm. 3 point charges plus 3 microcoulomb, minus 5 microcoulomb and minus 5 microcoulomb are kept on vertices ABC respectively. Find the force on 2 microcoulomb charge kept on midpoint of BC. So this is an equilateral triangle having sides. This is ABC and charge A plus 3 microcoulomb, minus 5 microcoulomb and minus 5 microcoulomb, and the charge is kept at the midpoint of BC. BC. 2 Coulomb charge. This is T and charge is 2 microcoulomb. Now we know that this is perpendicular for the property of the isosceles as well as equilateral triangle. This line AD will be perpendicular on BC. Now the force acting on 2 Coulomb charge due to minus 5 Coulomb charge, and this is minus 5 Coulomb charge. These 2 minus 5 Coulomb charges are in equal distance. This minus 5 microcoulomb charge will exert a force in this direction as it is positive and this is negative, and this will exert a force. So the resultant force due to this 2 minus 5 microcoulomb charge is 0. So remaining charge is plus 3 microcoulomb. So force acting on it will be due to the 3 microcoulomb charge, and which is directed in this direction, that is in AD direction. Now what will be the force, magnitude of the force? Side of the equilateral triangle is 20 centimeter and height of this, we know that h is equal to root 3 by 2 into 20, that is 10 root 3 centimeters. So R is equal to 10 root 3 into 10 to the power minus 2 meter. So force is equal to 1 by 4 pi epsilon 0 plus 3 into plus 2 Q1 Q2 divided by R square 10 root 3 into 10 to the power minus 2 whole square is equal to this is 9 into 10 to the power 9, and this is 6 divided by 100 into 3 into 10 to the power minus 4, 2 Newton. 18 into 10 to the power 11 Newton along AD. ABCD square of side R, 4 point charges Q are kept at 4 corners of the square. Find the magnitude and direction of force on each charge due to other. Okay, and this is a square ABCD and side R and charge Q at 4 corners. Now if we consider this point, due to B, force will be in this direction. Due to D, force will be in this direction. and due to A, force will be in this direction. Now magnitude of this force is equal to Q square by 4 pi epsilon 0 into R square. This also Q square by 4 pi epsilon 0 R square. And this will be, we know that length of the diagonal of the square is equal to R root 2. So this will be Q square by 4 pi epsilon 0 into R root 2 whole square. That is equal to Q square by 4 pi epsilon 0 R square into 2. Now the resultant. It is clear from the figure that this force and this force, angle between these two forces are 90 degree and they are equal in magnitude. So their resultant will act along the diagonal, that is, it makes 45 degree with it. We can calculate it in this way, or we can calculate in another way. If you resolute this force in two mutually perpendicular direction and then add these forces and get the resultant. In second method, it is 45 degree and component of the force along AC is along DC direction is equal to Q square by 4 pi epsilon 0 into 2 into R square into sine 45 degree or cos 45 degree, that is equal to 1 by root 2. This is, suppose this is in I direction, and this in this direction equal magnitude Q square by 4 pi epsilon 0 into 2 R square into 1 by root 2. This is in J minus J direction. If it is taken, this is Y direction, negative Y direction. So the resultant force will be square root of sum of the square of these two, that is Q square by 4 pi epsilon 0 R square plus Q square by 4 pi epsilon 0 into 2 R square into 1 by root 2 is equal to, if you take Q square by 4 pi epsilon 0 R square common from both, then we will get 1 plus 1 by 2 root 2 is equal to 2 root 2 plus 1 by 2 root 2 into Q square by 4 pi epsilon 0 R square. This will have the same magnitude as this, also have same magnitude as it. So the resultant magnitude of the resultant is equal to this into root 2. So this will be 2 root 2 plus 1 by 2 root 2 into Q square by 4 pi epsilon 0 R square into root 2. Because if x, say AI plus AJ is equal to root over a square plus a square is equal to magnitude mod of this is equal to, so it is a root 2. So cancelling, I get 2 root 2 plus 1 by 2 into Q square by 4 pi epsilon 0 R square.